Hello, everyone. On behalf of Cenosco, it is my pleasure to welcome you to our 19th webinar about asset integrity management. My name is Omar Rujbani. I'm the Partners and Alliance Director, and I will be facilitating this webinar today. Today's topic is important, I believe, to many of you here, and it is about how to measure your safety instrument systems, SIS performance. Let me start my part by introducing our guests. We have invited two industry experts to shine some light on this matter, Brian Nixon from Hexagon and Peter Boulevard from Cenosco. Brian Nixon received the Bachelor of Science in Chemical Engineering with a minor in Computer Science from Rose-Hulman Institute of Technology. His early career was as a process plant engineer in the process industries, including agriculture processing, specialty chemical manufacturing, and plastic compounding. He then transitioned into control systems consulting, business development, and software product management rules. He is currently a senior strategy enablement consulting lead with Hexagon Asset Life Intelligence Division. Peter has a career spanning 25 years in the oil and gas industry. For the past 15 years, Peter has specialized as a functional safety engineer, working on projects in Shell, P&T, KNPC, and Equinor, to be naming a few. In 2021, Peter brought these years of experience to join Cenosco and take on the role of IMS-SIS SIF-Pro domain expert, where he is responsible for the functional integrity of IMS-SIS, as well as defining future users or legislation-driven development of IMS-SIS. So, before we start, let me outline the framework of our webinar today. We will be starting by exploring the what is and why do it of SIS barrier performance assurance. Then we will continue looking at the strategies on how SIS barriers performance assurance can be achieved on production sites and what challenges engineers may face when implementing a strategy. We will also conclude with a short conversation about efforts versus benefits of SIS barrier performance assurance implementation on product sites. At the end, we will have some time to answer questions. We have already received a few upfront, but please feel free to put any questions that you may have in the chat. Also, please note if for any reasons you experience bad connection on your side, a refresh of your browser will bring you back into the webinar. So, hi Brian, how are you doing today?
I'm doing quite well, Omar. Thanks.
Thank you. Peter, how are you?
Doing good, Omar. Good to be back with this webinar again.
Thank you. So let's start with you, Peter. Our topic is how to measure your safety instrumented system SIS performance. Can you first explain why production sites should be interested in measuring their SIS performance against SIS key performance indicators?
Yeah, thank you, Omar. Well, the short answer to that question is basically because IEC 61511 tells you that you need to do that. And it's also a question that we get a lot from SIS focal points on production sites and customers. that they are asking themselves how is my SIS performing against the design intent that we have for our SIS. How is it performing against key performance indicators? So to understand how well a SIS is performing against certain key performance indicators, sites are struggling a lot of the time with the implementation of how to measure this SIS performance against these key performance indicators. But before we go into the details of the implementation part, I think it's good to understand first, the why. Why does IEC 61508 tell us that we have to monitor these key performance indicators? So on this slide on the screen, you can see the safety life cycle as presented in IEC 61511. Many of you, of the people that will be joining today, will recognize this picture. But what's really interesting about this picture, in the context of our webinar today, is that it's actually split into two distinct phases. The first being the design phase, which basically starts from clause 8 all the way up to maybe clause 14 and 15, is where all the design has taken place of your SIS system, where you take basically in your design data in your calculations, data in your LOPA that are based on literature, such as ORIDA maybe, or any other statistical data that you use for these processes. And the second phase that is clearly distinct in this picture is seen from clause 16 onward, basically, and that's the operation, from the operation and maintenance phase onward. And that is where you basically, that's the real life situation. You're not in the paper phase anymore. This SIS is now live and operational, and IEC has recognized this. Yes, this if you will, this gap between the assumptions that you make about your SIS and all the equipment that you use in your SIS and all the data that you've used for the calculations and the LOPAs in your SIS design. That gap, that is there between the design world and the real life world. And, you have to verify whether your assumptions during the design phase actually hold up against the real life world. So that is the first part of understanding why IEC tells us that. And IEC speaks of this in quite a few different places in this big document. But I think the clearest, where they describe it most clearly, is shown over here, which is an extract from section 5.2.5 in IEC 61511. And that's what I would like to focus on for now. So it states that procedures shall be implemented to evaluate the performance of the SIS against its safety requirements to to identify and prevent systemic failures, to monitor and assess whether the reliability parameters align with those assumed during the design. So that is, basically already stating over here, you have to monitor and assess whether your reliability parameters of your SIS, as it is in production, align with those assumed during the design. And to define corrective action if the failure rates are greater than that was assumed. Now, you can only take corrective action, of course, if you know that corrective actions need to be taken, right? So you have to start measuring the SIS performance. And the last, but the last item is compare the demand rate of the SIF during the operation with the assumed demand rate during the risk assessment when the SIL requirements were determined. So IEC focuses a lot on basically these parameters: demand rate of the SIF and reliability parameters, such as failure rates, for example. And why is that? Yeah, because IEC 615, 508, and 511 focus very heavily on the safety of assets, the safety of people, the safety of environment, right? Through all these procedures and measures and calculations. And if you look at it from a specific, SIF point of view, then the risk analysis, part, for example, a LOPA determines the PFD target in this formula over here, And if the PFD target changes, that means, that or the SIL gets higher or the SIL gets lower, that means that you will have to do something on the other end of the formula in order to ensure that your PFD average will still, of your SIF, will still be below the PFD target, as set by the risk analysis, such as a LOPA. So the demand rate is a very important factor in, the SIL determination, basically. So the higher the demand rate, typically the higher the SIL will get. So that's why IEC wants us to monitor the demand rate, because you might be out of a tolerable area currently with your PFD target. You might be having a higher demand rate, leading to a higher or a lower PFD target, which means that you need to do more frequent testing in order to achieve, staying below this PFD target. And also, if you look at it from the part of the this formula again, but now from the SIF design part onward, if your failure rates, if you assumed during your design, do not match up with the real life world, then also you might need to do more frequent testing in order to stay below the PFD target as set by the SIL. To ensure that you are, your risk is tolerable. So these are two very important parameters for the IEC documentation. And that's why they so heavily focus on these. And basically this formula explains a little bit why, why we need to focus on these two, because they are important in terms of, your calculations that ensure that you are within tolerable risk levels, that you do not fall outside of that. So that is why the focus from IEC on that a lot. Brian, maybe also to you. What are your thoughts on, from your perspective, from Hexagon's perspective, on the value of monitoring these safety system performances?
Thanks, Peter. As the old saying goes, you can't improve what you can't measure, and we all want to improve process safety of our facilities. Being able to measure the performance of the various layers of protection in an industrial facility is pretty critical to understanding the overall risk of what it is we're doing, and also improving the overall resiliency of the operation. The goal is to avoid those loss of primary containment, or LOPC, events. The United States Chemical Safety Board, or the CSB, has actually long advocated for the use of effective leading and lagging indicators of process safety performance. The idea being the more leading indicators you can develop, the more problems you can solve while they're small, before they lead to those loss of primary containment events. In order to meet a lot of the CSB's recommendations, the various industry groups have developed some guidance around what to do and how to interpret process safety metrics. So to that end, the American Petroleum Institute, or API, created Recommended Practice 754 on process safety metrics. API 754 is conceptually based on the tried and true incident pyramid when it comes to safety events. Where the bottom is going to be first aids, and it kind of moves up, and then the top of the pyramid is fatalities, right? The idea here is that you're going to have a lot more events on the bottom layers of the pyramid that hopefully, if you address them at the bottom layers of the pyramid, it doesn't climb up the tiers and result in much more significant consequences and severity events. Okay. So in this particular type of pyramid, the most leading indicators are at the bottom of the pyramid, and the most lagging indicators, the loss of primary containment events, are at the very top of the pyramid. So in this model, Tier 3 is classified as challenges to the safety system and is considered a leading indicator of overall process safety performance. The safety systems perform a very important function. They turn the process off, right? They shut everything down and make sure that it is in a safe state. So every time that there's a demand on the safety system, you're rolling the dice, right? So every time there's a demand on the safety system, it has one of two possible outcomes. It'll work or it won't, right? And we've designed these safety systems to ensure that they will function nearly 100% of the time. Why? Because they need to, because they have to. Because when they don't, it is a process safety critical event. Okay. So being able to understand the number of times we're asking the safety system to do its job and being able to compare that information with the design lets us know if we're inadvertently exposing ourselves to greater risk. While IEC 61511 Section 622E requires that information be maintained on SIS failure and demand rates on the SIS, there's not a whole lot of recommendations on any specific metrics used to evaluate the performance. Other industry groups have also provided some guidance around understanding metrics for process safety. For example, the Center for Chemical Process Safety, or the CCPS, has also published a book called Process Safety Metrics on this very topic. So I'm happy to say that this is an area that has gotten a lot more attention in recent years, with several industry groups publishing guidance on how to measure and monitor the overall health of all of the different process safety barriers. And one of the things that we've found throughout the years is as more industry groups start publishing guidance, the more regulators start to take notice and start enforcing various different rules.
Thank you, Brian. The from the IEC, IEC says that you have to do it, but does not really tell you how to do it. So, what are some of the metrics that we can use to let users know how their SIS is doing? And maybe Peter?
Yeah, thank you, Omar. Yeah, so there are many different metrics that you can use, I guess, to start measuring your SIS performance. So on this slide, I've named a few of them, yeah, because they will resonate most with our audience, I think. But they, it's not just excluded to these, but it would be useful, for example, if you want to know how your SIS overall is performing, yeah, to, for example, start recording the number of trips, yeah, the number of successful trips that you're having, the number of failed trips that you're having, and these could be valuable metrics, because if you start recording this, then basically over time, you can basically start trending those data points and see maybe if year on year you see more failed trips occurring than the previous years, or the number of total trips is over the years steadily going up, and that in itself is also valuable information on your on the performance of your SIS, because there might be some mechanisms in play either in the process or in your SIS that mechanisms, maintenance or degradation mechanisms that will basically degrade your SIS over time, that need attention. So although it doesn't immediately give you a smoking gun, trending this kind of data points will give you a starting point, to start investigating. Hey, I'm seeing the number of failed trips go up year on year. Is there some sort of, common denominator there? Is there something where we can, focus our attention on? Is there a degradation mechanism at play? Yeah. And another one that I've mentioned over here also is to, for example, start monitoring SIF response time versus SIF process safety time. And also that will give you some insight, in the performance typically of valves, because those are typically the most, influential factor in SIF response time, rather than the sensor or the logic solvers. But also there, if you see a trend going on that, your SIF response time, or, is going up year on year, for example, whenever a valve is called upon, also that could give, maintenance engineers an idea, hey, this is odd, why is this valve closing slower and slower year over year? Is there some sort of maintenance issue with that? Yeah, it doesn't give you the smoking gun, but it gives you a very good starting point to start investigating the performance of your SIS, before it becomes so bad that you might exceed the process safety time of that particular SIF. And basically, it cannot achieve its safety mission anymore. So from that perspective, once you start collecting these, and measuring SIS key performance indicators, in a thoughtful and structured manner, you can also start visualizing that information to key functional safety personnel on site that will allow them to make well-informed, data-driven decisions when it comes to the performance of that safety instrument decision. So I don't know, but Brian, do you have some thoughts on this from your end, maybe?
Yeah, I do, Peter. And these are all great metrics. And there's some additional metrics that could be beneficial in really understanding the overall operational performance, right, of a SIF, right. So one of the things that our customers are sometimes challenged with is understanding what are the active bypasses on a given SIF, and how often do I use them, and how often do they remain in a bypass mode, right? When a SIF is bypassed, it's not going to perform its function, right? And so this ends up being a pretty important thing to understand as when it comes to understanding the risk of what it is you're doing, and the risk of ongoing operations is understanding, what are those signals that get bypassed, and are they getting bypassed appropriately, or are they getting bypassed at a startup and forgotten about, right? These are all different areas of risk. So understanding the overall bypass frequency and duration, and making sure you've got good, solid processes and procedures in place to make sure that you're monitoring those bypasses becomes pretty important as well. You can also take a look at things like instrument failures and how often your 2 out of 3 voting scheme might be degraded because of some type of instrument failure. Okay. Also, when you've got a safety function that you've claimed a risk reduction for, it's usually not the only safeguard in the chain from the hazard to the consequence, right? So in many cases, there are going to be intermediate safeguards, like the operator response to an alarm, or an automatic control loop is intended to mitigate a particular process disturbance. Okay. Metrics around those layers of protection can also be really good leading indicators to, again, solve problems while they're small, solve problems before they hit the point at which the safety function will activate. Monitoring the ongoing performance, again, is pretty key to understanding if SIFs have been over or under designed. Integrating these metrics back into the design software and your PHAs and your LOPAs can be really beneficial to understanding if the performance is in line with the design throughout the operation of the facility. Find the areas where you might be being exposed to additional risk. And again, the whole point of metrics is to find and address problems while they're small, while they're relatively leading indicators, before you start hitting those major lagging indicators.
So, knowing all of this now, there will probably be some implementation challenges, but there will also be an opportunity when you start measuring your SIS performance against SIS key performance indicators. Uh, if I ask you, Brian, what challenges have you come across in the projects that you were involved in?
In a lot of cases, the challenges that we run into is, when people first hear we want to monitor the performance of our safety system, it's kind of like this giant elephant, right? And how do you eat this elephant, right? So we see challenges in industry relating to how to even get access to the data they need to perform these types of metrics, right? To really understand and assess the performance of the safety system. There's a whole bunch of different places where the data could reside. It could be in a PHA LOPA, could be in a whole bunch of different spreadsheets, different procedures, maintenance records, process drawings. Many sites just don't have the resources to continually update these performance metrics because it's difficult to get at all the different sources of data. We've heard that it can take up to a week of somebody's effort to produce monthly metrics around the tier 1 and 2 events. And they're not even taking a look at the tier 3 and 4 events that are more leading indicators. So if it takes a week to do just the tier 1s and 2s, it's going to take a little bit longer to do the 3s and 4s. Okay. We've also found at a lot of sites that sometimes people overlook the value of the information being generated by their control system. It's a great resource for a lot of great information about the performance of the various layers of protection. As I mentioned, operator response to alarms. Well, the control system is generating time-stamped events of all those alarms. The control system generates data around the performance of control loops, for example, that might be involved in various safeguards. And a lot of times the control system is producing logs of these trips themselves, when the trip is initiated, when the valve is commanded to close, when the final element actually does what it's being told to do. Okay. So the control system produces time-stamped event logs of instrument failures, trip initiators, final element actions, etc. These SIF-specific events can be filtered from the volume of data generated by the control system to produce these metrics. How many times was it asked to perform its function? How well did it do against the process safety time by measuring the time difference between when the valve was told to do something and when the valve actually did it? Now you know how long it took the valve to close, right? And so a lot of times the information from the control system can be filtered down to the specific SIFs of interest to be able to understand a lot of the performance. So if you've already got an alarm management system in line with ISA 182 and some other industry standards, right, that's already consuming this data from the control system, you probably already have a pretty good start to being able to understand the performance of your safety system. And again, a challenge that we have seen with using the control system data is sometimes the tag on the control system don't always match up with the tags on the PNID that were used to generate the HAZOP and LOPA design information. So you've got a little bit of effort there to map the corresponding tags in the event data from the control system to the tags that were used in the PHA and LOPA. However, this is just kind of a one-time setup exercise, and once completed, the data collection, analytics, reports, and metrics can be readily automated.
Yeah, I think you you were right there, Brian. There's a lot of data, a lot of considerations to make. So there will be challenges, as you stated before. But so there will also be, in my opinion, once you start measuring all these parameters, there will also be great opportunities for users. And one of them, which you already touched upon as well, is that you start making data-driven decisions on safety, economics, or environmental, right? Because you might already start recognizing patterns and before it becomes a problem, as you say, if you start collecting some of this information. The example of the valve, that the closing time goes up and up over the years, right? So once you start collecting data, you start knowing, and you can make proper decisions, and you as a user will be in control basically of your SIS performance. Then you will not be second guessing anymore and thinking and reverting back to design data, but you will actually know and be in control of that system. So I think those are two very important things. Yeah, you can start detecting, problems before, they become bigger, before they escalate. But there are potentially also economic opportunities, because it's not always doom and gloom in that sense. So I've put a small example on this sheet over here, yeah, and for a typical site, and there you can see that yearly testing cost alone is for a typical site, might be more than $1 million on a yearly base. So that's a lot of money. And once you start measuring data, and once you start measuring these demand rates or these failure rates, you might actually also find out that you've been too conservative in some cases during the design phase, and that there is maybe a little bit of room for relaxing. So even if you get 5 or 10%, if you can shave 5 or 10% on a yearly basis, off of that $1 million that you spend yearly on testing, just for SIFs, just SIF testing, then that would already be, quite a, reduction in testing costs yearly. So it's from that perspective, it's not all doom and gloom. I would say there's also opportunity to be had for any company that starts measuring measuring its SIS performance against key performance indicators. Yeah.
Great. I think it is time now to conclude. Maybe before we conclude, I would like Brian to say some final words, and then I will give you also the floor, Peter, to do the same.
Thanks, Omar. We live in exciting times. Beyond the marketing buzzwords of digital transformation and digitalization, we're actually seeing a lot of companies embrace the amount and volume of data that they have available to be able to leverage it for different applications and different use cases. Okay, so this is an area where digitalization and the digital transformation of information and data from a control system can be used to really impact the overall process safety and understanding of the risks of what it is we do day in and day out. There's a lot of guidance that's available from various industry groups like the CCPS, the CSB, the API. There are other groups as well that have been publishing guidance documents around this very topic. Right? And so it's a good time to start leveraging the data that we already have available and making sure that we can use it to really make a step change improvement in the way that we operate our facilities and really drive safety, environmental compliance, and of course the overall economics of the process as well.
Yeah, I concur to that, what you just said, Brian. It's the world is waking up to this as well. And the value of measuring and the value of knowing and getting in control of your SIS. So I would like to basically stick with that for now, and maybe see if we can, if we have some room for questions as well.
Thank you both. Let's then move on to the questions. We have some questions that were sent beforehand, and also we'll take some questions from the chat. Let's start with the first question. Are there any industry standards, guidance around digitalization of functional safety? Brian?
Yeah, there's actually a couple of working groups from the ISA that are specifically looking at the digitalization of functional safety. It's an offshoot of the ISA 84 committee, and the ISA 84 committee is the safety system committee that a lot of their content ended up getting incorporated into 61511. as well. So there are a lot of industry groups that are really looking at, what are the costs of doing some level of digitalization, but what are the things that we can drive out of it? They're not looking at digitalization or digital transformation just for the sake of doing it. They're really looking at what are the use cases that I can improve, streamline, and make more effective by being able to harness the power of the data that I'm already generating in many cases. So yes, there are some industry groups out there that are largely working on technical reports to let people know the value of harnessing your data.
Thank you, Brian. I have two other questions from participants that are closely related here. So the first one is the feedback from performance to design. How is this established? And the other one is how do you bridge the gap between the design and the operations? Any insights on this, Peter?
Yeah, thank you, Omar. So yeah, that's an interesting question, and there is no one answer to that, or no, one size fits all, one single solution to that, because there are different IT infrastructures, or typically on sites, different software packages that are being used on sites typically. So it's there is no one size fits all. What I would like to point at, is what we in our technology collaboration with Hexagon IPL Assurance are working on currently. What we've set up is to have IM-Assist and the design data that typically resides in IM-Assist, such as failure rates, such as the LOPA, such as the HAZOPs, the demand rates, barrier PFDs, all that data that is being used in all these design calculations for your LOPA or for your SIF design verification calculations, is in IM-Assist, is readily available. And Hexagon is really good at extracting all this data from all these DCS systems, IPS systems, sequence of event recorder. So in the collaboration that we've set up, we create, we communicate that data, where we generate a data pool where we have all this information from these two different worlds that IEC, this life cycle, where you see, the top part is the design part, which is IM-Assist basically, and the bottom part, is operational, which is Hexagon IPL Assurance. And we connect these two worlds through our technology collaboration, so that you as a user can start visualizing that and can start extracting that data for your purposes, to start measuring these KPIs, to start measuring the overall SIS performance. How many demand rates have I had on a SIF for the past year, and is it going up? Do I get more frequent failed trips? So of course, all of this data will have to be crunched, because otherwise data is just data, of course. So it's not just that, like a plug and play where you connect the two dots. You still have to think about what data, what constitutes a failed SIF, for example, right? When is a SIF successful in its safety mission, and when is a SIF, when did it fail in its safety mission? So there, it's not straightforward, but it does connect these two worlds, where both of these software packages, IPL Assurance and IM-Assist, can benefit from each other's data and can start visualizing it to the user, so that whatever your role is in the functional safety, in the world of functional safety, that you can access that data and take data-driven decisions, basically, and that is really important. You start making decisions when it comes to functional safety based on real measurements, and I think that is really valuable with this technology collaboration, that technology solution that we are projecting together with Hexagon IPL Assurance.
Okay,
So
thank you,
that is
Peter.
basically, it's not a one size fits all, but it's a really good question that the user asked. Yeah.
We'll have more. We have more questions coming. I'm just concerned about the time, but let's take this question. Could you explain more about the process safety time, Peter?
The process safety time. All right. Yeah. So this is the process safety time that I referenced before. So normally, I'll quickly try to explain that. So normally, whenever you do a LOPA or a SIF design, it also has to act within a certain time span. Typically, that can be quick, that can be slow. Yeah, if you look at how quickly does a SIF need to close an inlet valve of a storage tank before it overfills? Yeah, well, that's typically quite some time. So you've got quite a big process safety time. Yeah, it's the time between the activation of the SIF and the actual consequence occurring of overfill. So the time is typically quite low, the process safety time. And there are, also some scenarios, that you can think of, that, your SIF needs to respond like really quick. Yeah. Liquid filled systems, for example. Yeah. Overpressure on liquid filled systems, but also high vibration trips on compressors. Those are trips that, valves need to close really quick, because if you let it go on for 5 seconds, this vibration, then the whole thing might shake apart. The whole compressor might shake apart. So you have to think it in that way, right? So by the time you detect the anomaly till the time that, the consequence occurs, the compressor shaking apart, for example. Yeah. That would be the process safety time.
Thank you, Peter. I will take another two questions before closing. So this is for you, Brian. The question is, I would like to talk about the formulas, methods, and tools for calculating the performance of SIS.
Okay. So at a
Just
very
high level, Brian. Yes.
Yeah, understood. At a very high level, what you want to do is you want to compare the actual performance of the safety function to the performance that you assumed when the function was designed. So, for example, in your LOPA or in your HAZOP and your LOPA exercises, if you said that this particular hazard would occur once every 10 years, okay, if after reviewing the actual data from the process, you found that this function was getting asked to perform 10 times in a single year, there's obviously a really big difference between the assumed demand rate and the actual demand rate. So because there's such a discrepancy there, it leads you to understand that maybe your safety function, since it's being activated and demanded by the process much, much more frequently than was designed, you're actually exposing yourself to greater risk. Again, every time the SIF activates, you're rolling the dice, right? And your goal in process safety is to make sure the probability of failure on demand is as low as humanly possible, right? That function will last every single time. Well, the more times you roll the dice, the more times you're placing yourself at risk of that possibility of failure. Okay. So when you're talking about formulas, methods, and tools for calculating the performance of SIS, there's a bunch of different ways to take a look at it. There's the overall function demand rates. Are my function demand rates in line with what I said they would likely be in my PHA, HAZOP, or LOPA? Okay. The other side of it is, how available is that system? If it's got inputs that are bad, or if it's bypassed, it's not available to perform its function. And safety functions are often designed with a very high availability rate, better than 98% of the time, right? 99, and just start adding nines based on how many SIL levels it was designed to be, right? So it needs to be available. When it comes to what Peter was describing with understanding valve performance over time, right? As a former process engineer, man, that's statistical process control, right? That has run chart written all over it. Every time I stroke that valve, I can take the time difference between when I told the valve to close and the time-stamped event from when the valve actually closed, and I can trend that over time. Everything that moves eventually wears out and breaks. So if you start seeing on a trend test, using your upper and lower control limits, if you start to see the valve performance degrade over time, you know something is going on in that valve, right? It's not random as far as the times go. You see a definite trend test in your statistical process control algorithms. You can use that to plan when to overhaul the valve and when to make sure that it gets the preventative maintenance to ensure that it will continue to function the way that it needs to, before you end up in a situation where the valve no longer closes in the amount of time that it needs to close in. Okay, so at a very high level, that's some of the different methods and tools that can be available for understanding the performance of your safety instrumented system.
Thank you, Brian. Let me take this last question. It says from one of our viewers, how to measure number of failed trips. And I think he's mentioning here, I think it is in most of the cases, when we have SIF failure, we have a mechanical barrier which been triggered, or even we could have an accident. So our goal is to prevent this. I think we should focus on monitoring of SIF response. Comments?
Yeah, so it's always a little bit. This is what I was referring to before, very quickly before we run out of time. Is that what constitutes a failed trip, or what constitutes, a successful trip? So first of all, you would have to know which valves have to close as primary final elements on a certain trip condition. So that would be the first thing that you need to know. But then you also need to have the information from the automation system, either from the DCS or the IPS, to tell you when a valve has successfully achieved its safety mission. So a good example for that would be a closed indication on those valves that need to close on that trip indication. And we also realized that, if you're building a greenfield, you probably will have all this in a greenfield, but on brownfields, you might not have all this information, such as close indications, proximeter switches to measure the close in position of a valve even. And then you would have to basically look at these valves individually and see if you can find another indicator that you can extract, such as, for example, a flow sensor that is just downstream of that valve. If it indicates 0, that you know that your valve is closed successfully. So again, there is no one single, there is again no one size fits all. It really depends on the buildup. Yeah.
Thank you, Peter. Again, Brian, Peter, our time unfortunately has run out. Thank you both for this informative discussion on measuring SIS performance against SIS key performance indicators. And for all the viewers watching, thank you very much for your time. Please take a note that this webinar will be soon available to download from our website. And you know that you can contact Peter or Brian for more information. Our next IMS webinar is going to be in December 10th, so we look forward to see you again. And thank you. Bye-bye.
Thank you all. Thanks for joining.
Thanks, everyone. Great discussion.